Good morning. Today we're starting a new unit. We're going to be talking about roots and radicals. We've touched on regular square roots a little earlier in the semester, but today we're going to change the index, which is the little tiny number on the outside. So we're going to be changing that, and I'm also going to be adding some variables to our square roots. So we'll still go through. It still starts with a factor tree, but we're just going to branch off and extend our knowledge of square roots. So things that we already know the square root of 25 is 5. We already know the square root of 81 is 9. We already know the square root of 144 is 12 because those are common perfect square numbers that we work with. We know the square root of 64 is 8 and the square root of 225 is 15. So those are perfect square numbers that we commonly work with. Today we're going to be changing the index and taking a look at some different things. So this one here, I have a 3 is my index and 8 is the number on the outside. So this is the cube root of 8. So we are looking for the cube root of of 8. So that means what number times itself 3 times is going to give me 8. So something times something times something, same number. What is the cube root of 8? So that number is 2. And I know that because 2 times 2 times 2 gives me 8. So the cube root of 8 is the number 2. So that would be the answer for the cube root of 8. I could do the same thing with this one. I'm looking for some number. I'm looking for the fourth root of 625. So some number 4 times is going to give me 625. So the fourth root of 625. So something times something times something times something, same number. 4 times is going to give me 625. So that number is 5. So that's where I got 5 from earlier. I was jumping the gun a little bit. So the fourth root of 625 is the number 5. 5 times 5 times 5 times 5 gives me 625. We'll go through and do one more. So again, this number on the outside is called an index. So it's a little tiny 5. This one is a little tiny 4, a little tiny 3. So the fifth root of 243. Some number 5 times is going to give me 243. So that number is 3 because 3 times 3 times 3 times 3 times 3 gives me 243. Now, these are all numbers, no variables. We can type that in Desmos or some sort of graphing calculator, and it will give us the answer. So the cube root of 8 is 2. The cube root of 4 is 5. And the cube root of the fourth root of 625 is 5. I'm going to get it together today. And the fifth root of 243 is 3. So these are all numbers you can type in the calculator. So that's my point to that. So let's go through and do some problems. And we're going to do some factor trees. And we're going to simplify. We're going to find the cube root of 64, the fifth root of 32, etc., and so on. So these are numbers that you could type into Desmos. However, when I add variables and stuff in it, I want to make sure you understand how to do it because you can't put the variables inside of Desmos. So for the first one, I'm going to do a factor tree for 64. 8 times 8 is 64. 4 times 2. 2 times 2. Again, I got another 4 times 2 and 2 times 2. So all I did was a good old-fashioned factor tree. My index, which is a little number on the outside, my index is the number 3. So I'm looking for groups of 3. So the number on the outside tells you what groups you're looking for. I'm looking for groups of 3. So I have a group of 3 here because I have 3 2s, so that counts as one group. And I have another group here, so that counts as another group. So the little number on the outside tells you what should be in your group. If it's 2, you should have groups of 2. If it's 3, you should have groups of 3. If it's 5, you should have groups of 5. In this case, I needed to put them together in a group of 3. So I have one group of 2 and another group of 2. You will multiply that, and our answer is 4. So the cube root of 64. So the cube root of 64 is 4 because 4 times 4 times 4 is 64. So that's our answer. Let's go through and try another one. This time I'm looking for the fifth root of 32. So the fifth root of 32. We'll do a factor tree. This is 8 and 4. This is 4 and 2, 2 and 2, and this is 2 and 2. So I did a factor tree. This time I'm looking for 5 of the same number. So I'm looking for a group of 5. So 5 of the same number. So 1, 2, 3, 4, 5. So this is one group. I only have one group of 5. So this tells me what I'm looking for. I only have one group of 5. So my answer is 2. Because 2 times 2 times 2 times 2 times 2 gives me 32. So 2 is the fifth root of 32. C, go through, do a factor tree. I got 9 and 3, 3 and 3. My index this time is the number 3 because that's the number that I have up here. So my index is 3. I'm looking for a group of 3. So that would be here. So I have one group of 3. This negative is going to come into play because negative 3 times negative 3 times negative 3 is negative 27. So my answer to this problem is negative 3. So I added the negative on after I did my factor tree because a negative times a negative times a negative gives me a negative. D, so this is a really big number. So I started my factor tree with 2 and 2048. Okay, so that was a really big number. I started with 2 times 2048. Just because I knew it was an even number, it's divisible by 2. So if I keep going, then I broke this down into 4, 512. Break this down. This is 2 and 2. Break 512 down into 4 and 128. So it's a really big number. We got to keep right on going. Break 128 down into 32 and 4. Break this 4 down into 2 and 2. Break 32 down into 8 and 4, 2 and 2, 2 and 2, 4 and 2, 2 and 2. And let me adjust this so you can see my factor tree there. All right, so 4,096 was a super big number. Big, 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 big number. Okay, really big number. So I did 2 times 2048. Then I did 4 times 512. I did 2 times 2. I did 4 times 128. 4 breaks down into 2 and 2. 32 breaks down to 8 and 4. Break my 4s down, break the 4s down, break the 4s down. Okay, so you should have a whole bunch of 2s. So this was a really big factor tree. This time I'm looking for groups of 4. So I need 4 of the same number. My index is 4, so I'm looking for 4 of the same number. So we need to carefully pair all these 2's together so that I put them in groups of 4. So let me go through and try to put those. I'm using red here. So 1, 2, 3, 4. So I can put these together. Okay, so that's 1, 2, 3, 4. I got a whole bunch of 4s down here. I can do 1, 2, 3, 4. So that's another group. And I got 1, 2, 3, and this one is left over here. So I'm going to underline that group. So that's 1 here, here, and here. Okay. So I have 3 groups of 4. So I got 3 groups of 4. This is a group 1, 2, 3, 4. That counts once. Okay. Then I have 1, 2, 3, 4. That counts twice. And then I have 1, 2, 3, 4. So I have 3. Where's my camera? There I am. I have 3 groups of 4. So that means I have 2 times 2 times 2. So the fourth root of 4,096 is 8 because 2 times 2 times 2 is 8. So I got 8 is my answer there. Again, take your time with your factor tree. Break it all the way down to prime numbers. Okay, and the last one I want to take a look at is negative 243. So we're going to find the fifth root of the square root of negative 243. So this number is negative 243, and we're finding the fifth root of this number. So I'm going to start by doing a factor tree. I'm going to start with 81 and 3. I'm going to break down 81. That's going to be 9 and 9. Break down this 3. Break down this into 3. So I'm looking for 5 of the same number. My index on the outside is 5. So my index is 5. I'm looking for 5 of the same number. So 1, 2, 3, 4, 5. So I got 5 3s. And there's a negative on the inside, so I need to apply that to my answer. There's a negative on the inside, so my answer is negative 3. So the gist of this, with all of these, you're looking for your index. So we had a few 3s up there. We had a couple of 5s. We had a 4. The little number on the outside tells you how many times to pair your answers together. If you have a 4, you're looking for groups of 4. If it's 5, you're looking for groups of 5. If it's 3, you're looking for groups of 3. So that tells you how many times you're looking for whatever number, whatever factor that you have. So groups of 3, groups of 4, groups of 5, those are your index. I'm going to erase the board, and I want to do just recap 2 more problems before I add the variables and stuff to it. So feel free to pause if you're not finished copying. Feel free to just pause the video. I am going to erase some of these. All right, I want to recap how to just do our regular radicals that we did. It's been a couple of weeks ago. So I want to break down the square root of 20. So this is a recap. I'm going to break down the square root of 20. And then I'm going to break down 240. If you just see a square root without an index on the outside, then your understood index is the number 2. So I do not see a specified number here, so it's understood to be 2. And I do not see a number here, so understood to be 2. So we're looking for pairs. We're looking for 2 of the same number. So 20, you can start off with different things. I'm going to start off with 5 and 4, 2 and 2. I'm looking for pairs, which are groups of 2. So pairs. Okay. Complete groups go on the outside. Everything else goes on the inside. So complete groups of your index go on the outside. Everything else goes on the inside. So I got a complete group here, and my leftover prime number is 5. So again, this is a recap. We've done this before. Just bringing it back up because it's going to come up again. I'm just going to be adding variables to it. So my answer to that is the square root of 20. Let's do 240. So you can start off with different things. I did 2 and 120 when I did it earlier. This is going to give me, I can do 60 times 2. I could do 30 times 2, 15 times 2, and 3 times 5. So I break it all the way down into prime numbers. All the way down to prime numbers. So I'm looking for 2 of the same number. So that's what I'm looking for there. I'm looking for 2 of the same number. So I see 2 2s here. And I believe that is all that we have there. Those are my only final numbers there. And then I'm also going to make sure I put my prime numbers on the inside of the problem. And I have another pair that I didn't see. There we go. So I have 2 sets of 2. I got a set of 2 here, and I got a set of 2 here. So on the outside, it's going to be 2 times 2. And then on the inside, I have prime numbers left over, 3 times 5. So complete groups of the index go on the outside. I have a pair here, and then I got a pair there. Leftover prime numbers go on the inside. So my final answer is 4 square root 50. Again, that's a little recap. In the next video, we are going to add some variables. Same concept though, so don't get confused. We're still going to do a factor tree. Complete groups of your index go on the outside, and everything else goes on the inside.